Hi students and welcome back. In this video we will be discussing how to take a frequency distribution table and use it to make a histogram. Alright, so to start off, our data comes from the following frequency distribution table. So we have our x-axis is defined in our histogram, and it is of course the grooming time in minutes. So this will be our x-axis, and the frequency will be our y values. So if we now start to plot the information or plot the data, we're going to have grooming time on the x-axis and frequency is on the y. So for 0 to 9 minutes, we had a frequency of 2 people who had that kind of a grooming time. So we're going to have a line that comes out from the 2, and it should look something like this. Alright, wonderful. Next is 10 to 19 minutes, and we have 3 people who have that kind of a grooming time. So we're going to draw a line coming out like from somewhere near, maybe not so close to the 4, so somewhere between the 2 and the 4. We'll have a line coming out like this. So this is a bar in our histogram. Alright, for the next time interval for 20 to 29 minutes, we have 9 people who have that kind of a grooming time, okay? Oh, I'm just going to erase those 2 random dots there. So they have that kind of a grooming time, and we'll just connect to that line all the way up here, which should be close to 9. It should be symbolizing the value of 9. Alright, so the next interval is 30 to 39, and we have 4 people who have that kind of a grooming time, so that would be somewhere like this. And we continue our histogram. Last but not least is the 40 to 49 minute grooming time, where there were 2 people recorded with that kind of a grooming time, and we will draw the last bar just like this. And there you have it, boys and girls, ladies and gentlemen, we have our grooming time histogram. And I'm going to label the units, grooming time in minutes, and then this is just our frequency is on the y-axis. So use the data from question 1 to make a stem plot. So I'm assuming that this is a continuation of the question 1 right here. So we can create some sort of a stem and leaf plot. So I'm going to create the stem and leaf plot actually right underneath the data, because that's just where it is most convenient for me to do that. Okay, so for the zeros, remember these numbers are place values for the tens place value, and then the numbers following it are for the ones. So 0, we had 1 0, we had a 5. For the ones, or for the tens minutes, we had a 12, we had a 15, we had another 15. For the 20s, we had 20, 22, 24, 25, 25, 25, 27, 27, 28. For the 30s, we had a 30, 30, 5, 5, and for the 40s, we had a 40 and a 45. So that is this would be a stem and leaf plot of the data. Oh, and we forgot to answer, is the data normally distributed? And I would say yes, this data is normally distributed. So from the histogram, we can tell because there is a symmetry to the data. The axis of symmetry is right here. What's happening on the left side of the axis of symmetry is happening on the right. Therefore, yes, the data is normally distributed. All right. Take a look at the last digits of times in question 1, and what does this suggest to you about how the data was collected? So how the data was collected, it seems like the data was collected and it was rounded to the nearest whole minute. That's what I would say. Instead of a millisecond or a tenth of a second, all of the data was rounded to the nearest whole minute. All right, thank you for watching this video on question 1. We covered frequency distribution table. We discovered we went over how to write a histogram or how to do a histogram using a frequency distribution table. And we also just went over how to do a stem and leaf plot from the information from question 1. And we discussed this last question here. So to take a look at the last digits of times. Thanks for watching, and in my next video, I will be discussing, why don't we do this right now actually? Question number 5, using the data from question 1, what level of measurement is being used? This is discrete data. What level of measurement is being used? I would say everything's rounded to the nearest minute. So it's finite data. What if the data was measured to an exact time? It would be infinite. And would this be discrete or continuous? It would be continuous data if a stopwatch was used to collect that kind of information. Is this data categorical or quantitative? It's quantitative because it's measured, and it's actually ratio data. The average mean grooming time is 24.3. Is this value a statistic or a parameter? So statistics are derived from a sample, so therefore this would be a statistic. So thank you for listening to this recording, and next recording we'll go over measures of center starting with chapter 3.1. Thank you. Bye.